So welcome. I'm the Senior Director of Platform Engineering here at Tile. So I actually work on integrating our Tile technology into all of our partner ecosystems. So some of the recent projects my team has worked on is we enabled Google Homes to directly ring tiles. We launched the first tile-enabled laptop with HP back in January, and we recently announced a partnership with Intel to empower Intel-enabled laptops to behave as tiles. And so my team works on all of these integrations. I also lead diversity and inclusion at Tile, and after almost leaving the tech industry in early 2018, I've really been on a mission to keep other women in tech. I've been working in on large-scale consumer tech for 20 years now. Been here at Tile. Prior to this, I was at Apple, where I worked on Siri. I managed the music team during the development of the HomePod and managed the Apple TV Siri team. And we actually got a technical Emmy for that integration while I was managing the team. I live here in Silicon Valley and was very happy there was a blue sky yesterday and today after 4 weeks of smoke. So that's a little bit about me. Some of you may have thought I was going to give an engineering with empathy talk because it looks like some of the things I was giving that talk. I actually have a recorded version of that talk, so if you did think I was giving that talk, please reach out and I'm happy to send you a link to that. But today I'm going to actually talk about Tile. And so I actually wanted to start with Tile's mission, which is really creating a world where everyone can find everything that matters. And this really excites me because I really care about helping others. And I love the fact that, the only reason we're collecting data is really to empower our users. We don't sell our data. So we really are on, a mission to help our users. And we're really solving a universal problem. So it turns out that you actually spend an average of 15 minutes a day looking for lost things. And that actually adds up to 365 days over the course of your lifetime. And, there's $47 billion worth of lost items every year. I've been late to work looking for my keys before. 80% of people have been. And then the interesting thing is people are actually putting tiles on everything. We actually have people put tiles on turtles and pigs and horse harnesses. It's actually really impressive, the stories we get of what people use to track with their tiles. And, so how does Tile work? So Tile is a little Bluetooth device, and I'll show you a picture in a little bit of our Tile products. And it allows you can put a tile on something and you can find that item from our mobile app. You can double press on a button on a tile and that'll allow you to find your phone through something we call reverse ring. You can look at the map and see the last place seen where your tile was seen. And then finally, what I really want to talk about today is our finding network, right? And this is what really makes Tile special, right? And, our community is helping everybody else in the community find their lost things. And, earlier I was saying people put tiles on everything, right? And, some of the quotes I love is people say, hey, Tile saved my marriage. I've had multiple people actually tell that to me. I actually sent a friend of mine a tile from my quarterly allotment, and she messaged me the day she got in and was like, I've now heard that tile ring 4 times from my girlfriend's phone. Thank you so much, because you've made my life much easier. And so it's great seeing how Tile can positively impact people's lives. And, like I mentioned, people put tiles on everything. So the most popular things to be tiled are keys and wallets. but people put them on turtles, pigs, drones, you name it, it might have gotten tiled. Somebody put a tile on their mask. Actually, they have a favorite mask they've been wearing, and so they've tiled it, which I thought was cool. And so I mentioned I was going to talk about our tile lineup, and so here it is. We have our Mate and our Pro, which last year we put in user replaceable batteries for our tile products, and so sorry, 2 years ago, and then this last year we actually expanded the range on them. And then we had our brand new products from last year, which is the upgraded Slim, which is now credit card size and just fits right in your wallet and has a 3-year non-replaceable battery. And then the Tile Sticker, which is small and you can put on your remote or anything else, and it's also got a 3-year waterproof battery. And so, I mentioned the tile devices and the mobile apps, and that's just part of our tile ecosystem. And so, the ecosystem is made up also of lots of embedded devices and access points too. As I mentioned, my team worked on enabling the first HP laptop to behave as a tile. And then, we've worked with Comcast, and a number of Comcast set-top boxes actually scan for tiles and send us location updates. And we also have our premium service, which allows us to do things like smart alerts that actually will alert you if you've left your tile behind. And so this is actually a picture of the tile network from, when tile was kind of started, right? And so the idea is there's lots of users that have the tile app on their mobile phones, and they're scanning for any tiles they see nearby, whether it's theirs or somebody else's. And anytime they see a tile, it'll send us the location update up to our community. Up to our tile services, and it's anonymous, but that's how the community can really help each other find lost things. And so let me go into details about how this might work. So let's say Megan, back in the days when we were traveling, went to New York to visit her friend Jane, and she accidentally left her keys, which were tiled back in New York. She ends up in San Mateo and is like, I have no idea where my keys are, and looks at her phone and says, the last time they were seen was in New York a while ago, and she marks them as lost. The next time Jane or anybody else in the tile community happens to walk by Megan's tile, the app will send us a location update for Megan's tile. Megan will then get a push notification saying, hey, your tile is actually found at this location by somebody in the tile community. And so Megan knows now, hey, yeah, my tile and my keys are actually definitely in New York. And so how does the tile architecture work? Well, when you get a tile and you buy it, it's actually not advertising because we don't want it to run out of battery while it's in the box, and we also don't want anybody to activate it. And so the tile is in what we call shipping mode. And so when you buy a tile, it says, hey, install the mobile app, and you go through our new user process. And that process says to push the button on the tile. When you press the button on the tile actually starts advertising a certain UUID, Universal Identifier, which is specifically for activation. And the mobile app is scanning for that Bluetooth advertisement for 1 minute. And if it sees it, then the closest tile it sees it's advertising that, it will start a handshake to kick off the activation sequence. So it sends a message up to tile services saying, hey, I'm activating this tile. And then if it's a partner tile, it actually will generate a tile ID and an auth key at that time for that tile, and then we will activate the tile. Once a tile has been activated, it will start advertising a different UUID, which is FEED, and most of our tiles actually advertise every 2 seconds, and they'll pretty much continue to do so until their battery dies. And so I talked about BLE, which stands for Bluetooth Low Energy. And so, a lot of people don't know a lot about how Bluetooth actually works, so I wanted to go through a little bit of an overview of Bluetooth Low Energy and how it works. So Bluetooth Low Energy is actually a subset of classic Bluetooth and was part of the Bluetooth 4.0 specification. It was pretty much designed as a low power consumption way to send small amounts of data. At the time, both Apple and Samsung adopted it very quickly, and so it actually became pretty ubiquitous, and that's why there's billions of BLE devices available today. And so, as I mentioned earlier, there's this concept called advertising. And so when a Bluetooth device like a Tile is advertising, it's actually, and this is what actually makes it low energy, it's not actually advertising all the time. It only advertises for a small amount for every advertising interval. So the Tile, which is the peripheral in this case, advertises every 2 seconds. The central, which is the phone or an access point in our case, is scanning for a certain amount of time and then stops and then scans again. So the scanning frequency has to line up with the advertising interval for the phone to be able to find the peripheral. And so that's how advertising works. The second thing you can do with Bluetooth Low Energy is a connection. And this is how you're actually going to be exchanging data between the central and the peripheral. So first, as in before, there has to be a scanning process for the central to find the peripheral. And then once they've found each other, there's a connecting process, and then there's a connection interval. And so the connection interval is how long the two devices wait before they send a little bit of data back and forth. So they're aligned on sending data to each other while it's connected. When a Bluetooth device is connected, it actually stops broadcasting and advertising. And so we actually started, when we started Tile, our phones actually stayed connected to all of the tiles. And a little bit later, I'm going to talk about how one of our recent architecture changes has actually been moving more to a connectionless model and how that's impacted mobile and why. And so I wanted to talk a little bit about GAP, which is the generic attribute profile, which is actually how the data gets sent back and forth when the connection takes place. So the attributes are actually the short amounts of data, and pretty much it defines how the data is organized and exchanged. So each attribute has a unique identifier, which is a UUID, and it's transported and defined as characteristics and services. And so characteristics you can think about as like unions of pieces of user data along with the metadata that describes them. And characteristics can actually be thought of as kind of a type, analogous to a class. So, and then a service is a collection of characteristics. So for us, we have a Tile service, and then we have a number of characteristics within there that we can use. And so it's really a client-server model for sending the data between the central and the peripheral. And so at Tile, like I said, we use GAP, but instead of using it directly, our firmware team created a transport called TOA, Tile Over the Air API. And we created this so we could have security and authentication. So it allows for communication between the phone and the Tile using that client-server pattern I mentioned. And we have defined 2 GAP characteristics that we use for sending and receiving data. And so we have one that lets us use for sending a notification, and then another one for responding to that notification. And so we use GAT write without response as well as GAT notify. And so here's actually a picture of showing kind of how that handshake works on connection. And so, the first thing that BLE has to do is actually discover any characteristics before it can actually try to use them. And once you discover them, you can register for notifications on them. And then you can actually trigger reading the tile ID off of the tile or doing any commands. This is also how we do firmware updates, is over the connection, as well as ringing happens over the connection, both securely. And then, I mentioned, we're going to talk about scalable services. So this kind of leads up to the scalable services part of our conversation here. And so, services is our backend. We ran on Amazon, so this is on AWS. It's a 3-tier REST API. So we have a load balancer tier. We've got application load balancers for most things and an elastic load balancer for our events. Then the middle tier is our services layer. And so this is where really the bulk of the code is. And so our services are really divided up into 5 smaller subsections that the load balancer balances against. So one server manages our Alexa and Google Home traffic for our voice responses. One handles retile, which is our ability to purchase tiles at a discount after a year when your battery has run low. Our API service is all of our main services outside of location. So this is fetching tiles, fetching users, fetching clients. Location is actually our largest just single service. We get around 1.5 billion location updates per day. We store the last place seen in Redis, and then we store a 30-day location history in Aurora to power our premium location history feature. And then finally, our events stream is actually JSON events that are mobile apps and our window app sends, which is, when users click on the app, Bluetooth diagnostics, etc. And we actually get around 33 billion events per day as well. And those just get stored in S3. And so I mentioned location updates, and so I wanted to dig in a little bit about how we made this really scalable, right? And so our location updates are really a multiple producer consumer problem. And so we have the load balancers getting all of these location updates. And then we have a number of nutty worker threads that are processing them. We want those to be very quick and return to the clients as fast as possible. So very little happens in those worker threads. They pretty much just validate that it's a proper tile ID and proper request. At that point, it actually returns back to the client, and most of our location update processing happens asynchronously. The nutty worker threads actually add the location update up to a ring buffer. And so this is actually a pattern called a disruptor. And so it has multiple consumers. And we've got 8 consumers that are actually consuming off of that ring buffer and storing it into Redis. And then this picture actually duplicates itself. And there's actually another ring buffer that reads off of those consumers to store it in location history as well. And so this is how we've managed to scale to support as many location updates as we do. And so, what are some of our other challenges that we really are tackling? Well, on the data engineering side, we're really looking at, data quality and visualization, right? When you get so many location updates from phones, hey, those come from GPS. But once you start talking about access points, those might be user configured. How do we start validating those location updates? So that's been a pretty interesting challenge and something we might actually start adding maybe some machine learning around, which is pretty exciting. On the mobile side, we've built our own Bluetooth layer. We had to figure out how to do smart alerts and figure out how to do separation alerts. Our Siri shortcut actually requires 3 inter-process communications between Siri and our tile app, so we can actually know and show in the app that Siri is ringing your tile, right? And then we also run our own direct e-commerce site that handles a lot of our, revenue. And so that's its own team. But, in some companies, that would be the whole team of engineering, and yet that's just a small part of it. And so, what's the future vision? And so I had shown you that picture earlier. And so here's really where we're going, right? And so you see people with the Tile mobile app, but it's not just tiles anymore, right? We've got those orange circles, which are the access points, as well as, we've got tiles embedded in everything from laptops to headphones these days. And it could be in more things like backpacks and skateboards and more. And so, I've talked about the connectionless earlier. And so I wanted to talk about, here's one of the big architecture changes we actually made in the last year. And so one of the things that as I mentioned, when we first built Tile, the app stayed connected to the tiles. And we did that because that made it faster to ring when somebody wanted to ring their tiles. This caused a problem, though, with other audio devices like AirPods, especially if you had multiple tiles. And actually, as I mentioned, if you stay connected, it's not advertising anymore. So in the case where we have access points trying to scan for tiles as well, they actually wouldn't see the tiles nearby. We also have to figure out if once we went to connectionless, hey, now we have that reverse ring functionality. How do we wake up the phone if we're not connected? So this is actually some of the big challenges we've been solving. We actually finished rolling out connectionless. It took us about a year. It's actually pretty interesting because we have to roll out our firmware across all of our products, and then as well as slowly roll out the changes on mobile to support these things and actually see how it works. We can only do so much testing. We actually have to do a lot of testing, through slow rollouts of experiments to ensure things really work at the scale of our users. And then the other big project that we're working on is really private tile ID. So currently tiles could technically be tracked by their MAC address or via the tile ID, which you can read by connecting to a tile and read it. And so we wanted to make tiles completely secure and have the device not be trackable. So instead of having the tile ID that can be read, there's a hash tile ID in the advertising packet, and we're going to be using that for identification. This actually ended up being a benefit for access point partners because they actually no longer have to connect to read the tile ID to send us a location update, and that can actually help with battery because every time you have to connect to a tile, that actually uses battery. And then also it meant you could actually see more location updates because you don't have to connect to get a location update. So those are some of the side benefits of moving over to this, but from a protection perspective, yes, we're going to be putting the hash tile ID in the advertising packet. We have a big identification service we have to build in the back end that pretty much stores all of our hashes, and eventually we're going to start rotating the MAC addresses on all of our tiles to ensure that they can't be tracked. And so the last thing I want to talk about is a little bit about what I've said my team's working on, right? And so, we're working on things like voice assistant direct ring integrations with, we have the Google Home and Comcast integrations now with PCs. I'm really excited about the Intel integration and enabling, a software-based solution to allowing laptops to behave as tiles. And, we're really expanding into lots of true wireless headphones. We just launched a couple months ago our Skull Candy headphones, and it's great because you can actually even track them when they're off, which is something you can't do with AirPods, just FYI. And anyways, that's it for my tile talk. This is my contact info if you want to reach out to me. And yeah, you can also email me at josie@tile.com. And that's it for me.
Thank you very much, Jossie. Let's give a round of applause virtual. You can put reactions on Zoom. Quick question, anyone? If you have a few questions, Jossie, if you want to take one or two.
Yeah.
And, yeah.
Let me see. I will share the link with I can share the link with the tile presentation. So the August question is, how similar is tile implementation to the GATT spec? So we actually use GATT. We don't modify GATT. We just have our own characteristics that we use on top of GATT. So it actually uses just the regular GATT service. And then how do you do testing for all these services? Like, that's actually an interesting one. So recently I actually started using Bespoken to do my voice testing, which has been helping there. They're actually a voice testing service. My automation QA on Windows actually has automated, I think, like 85 or 90% of our Windows testing through automation there. And so it's actually, each team kind of has their own testing. And then we actually have a number of manual QA who really help us with the embedded partners, especially because that has to do a lot of like hand holding usually with working with each of them, and you can't automate that as easily. And
One last question.
one last question. Okay. What happens if you lose something and the person who finds it doesn't have tile? A question I got. So if anybody else around has the tile app, that will end up sending a location update, right? So somebody has to have the tile app for us to get a location update. So. And then if anybody has any other questions I didn't answer, feel free to ping me directly and I will try to answer them.
Thank you again. Yes, you can